So green transformation and materials then. Let's start talking about the flagships, because we have to explain that a bit. Let's say there is a coatings flagship.
Yeah, yeah. So this is in this research center we have a flagship on coatings, and that means that we brought several academics and industrial partners together to work on new coatings, and in particularly on 4 aspects. One is to make building blocks, and in particular building blocks from green materials. Say things, for instance, waste of wood, cellulose, or other materials.
You can make coatings out of waste of wood.
Yeah, we have, for instance, you will hear this later in this session, that we have take waste material from cellulose, and you can convert it in a coating that is, the first tests show that it's almost as good as your coating on your car nowadays. So the second thing is, of course, new ways. So that's new building blocks, new ways to do the chemistry. That is to say, how do you make, when you make a building block, to make a plastic, how connect them in a long chain or making a coating out of it. And you need new chemistry for that. Also, without, maybe organic solvents that are polluting, but using water, much more sustainable. Third, you have to find new ways to make films, because this coating you see here on this table, this is a very nice film. But on a car, it will be a different film. And when you have a can of cola, it will be a different film. So you have to get new ways how to make these films. And then methodology, equipment, we discussed this earlier today, there is an investment in a lot of advanced equipment to figure out how exactly are these processes making such materials.
And how do you do this?
And if we better understand that, then we can control it much better.
But how do you do this? How do you figure that out?
Yeah, we use all kinds of techniques, like what you can do, for instance, we have all kinds of so-called spectroscopy techniques, like using optical spectroscopy or Röntgen diffraction, like you take a photo of your chest, in the hospital, you can take a photo of a molecule.
But then you have a different kind of lens, I guess.
In the laboratories, there are techniques that you can follow chemical processes in real time. And so with different spectroscopy techniques, we can follow those processes and get insight in, for instance, if you have a reactive species that makes it possible that these things come together or form cross-links to form a nice network,
so this is
then we can measure it.
This is fundamental research, and what you're doing now is you're finding the solutions for what we will need in 20, 30 years' time?
Now, first of all, if we better understand, if we make for new building blocks, that can replace the existing ones on a more sustainable, renewable way. That's very important. Then, if we better understand how we can make these materials, that's also a big incentive. Third, if we can recycle the materials and we can build in that you form a nice coating, but we can take away when we don't use it anymore, and we can recycle it, that will be a real breakthrough, because we need to recycle plastics and all these materials. And so, and then the final thing, which is really important, is to make, for instance, smart materials. Let me give you an example.
Of smart materials?
A smart coating, that cleans your window automatically. Or here, I have here a scratch in my finger, you see?
I can see
when I
it.
keep it clean, it heals itself. But when you have a scratch in your car or in your smartphone, it will not heal itself. But in the future, in the coming 20 years, we will have self-healing materials.
But then you have livable materials, or
it looks almost like livable materials, yes.
Wow.
You are alive, no?
Yeah,
you can repair
I feel alive.
If you are healthy, you repair yourself.
Yeah.
Now, can we not invent something that materials repairing
themselves? And my cells renew itself.
And renew itself, and those kind of aspects. Of course, it will be different from the natural systems. But I think we can use those principles to make smart materials. Self-healing, self-cleaning, etc.
Wow. I only can conclude, dear Ben, that the future looks very, very bright.
It is exciting and bright, and it's extremely challenging for our young people.